He's already promised the reward when the court realizes the chessboard has turned one grain into a royal disaster. What looked humble becomes physically impossible. And the shocking part isn't the first square. It's what happens by the end. A king is so impressed by the invention of chess that he offers its creator any reward he wants. You might expect gold, land, or a mountain of jewels. But the inventor asks for something that sounds almost laughably modest. Wheat. Not treasure, not power, just grains of wheat arranged in a certain way. It feels like the easiest royal promise ever to keep. But that tiny request is about to become very strange. The inventor points to the chessboard itself. Use all 64 squares as the counting surface. Start with wheat on the first square, then continue square by square across the board. Nothing is dumped into one giant pile. The whole reward is tied to this neat little grid. That makes the request feel organized, visual, and harmless, almost like a court puzzle rather than a serious demand on the kingdom's entire food supply. Here's the rule that drives everything. Put one grain on the first square, 2 on the second, 4 on the third, 8 on the fourth, and keep going. Each new square gets exactly twice as much as the one before it. That sounds simple enough, and it is. But repeating a simple rule over and over can create numbers that stop feeling human-sized surprisingly fast, especially when the board has 64 squares. At first glance, the king has every reason to smile and agree. The first squares need only a few grains, then a few more, then a few more. Even after several moves, the piles still look tiny. The inventor seems humble, practical, maybe even generous for refusing treasure. But that first impression is exactly what makes this puzzle so sneaky. If the beginning looks this small, how could the full reward possibly be a problem? To analyze the request, we stop thinking in piles and start thinking in numbers. Each square contributes one term to a sum. 1, then 2, then 4, then 8, all the way up to the amount on the 64th square, which is 2 to the 63rd power. So the full reward becomes a single expression. 1 plus 2 plus 4 plus 8, and so on up to 2 to the 63rd. Now it's a math problem. This sum has a special structure. Every term is made by multiplying the previous one by 2, so it's a geometric series. That matters because geometric series come with a shortcut. We do not need to add all 64 terms one by one. Once you recognize the repeated doubling pattern, the whole board becomes much easier to calculate. The puzzle stops being about counting grains and becomes about spotting the right kind of number pattern. Using the geometric series shortcut, the total comes out to 2 to the 64th power minus 1. Written in full, that is 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709,551,615 grains of wheat. That number is so large it barely feels connected to the tiny piles from the beginning of the story, but it is the exact total produced by following the rule honestly across all 64 squares. The modest request was never modest at all. It only looked that way at the start. There's also a wonderfully quick way to see the total. The last square alone contains 2 to the 63rd power grains. In a doubling sequence like this, the whole sum is just 1 less than twice the final term. So total equals 2 times 2 to the 63rd minus 1, which gives 2 to the 64th minus 1. That shortcut shows how dominant the late squares are, especially the very last one. Now, the king's problem becomes obvious. Doubling growth stays small for a while, then suddenly rockets past anything practical. By the time you reach the later squares, each single square holds more wheat than ordinary storage could handle. The reward fails not because the rules were unclear, but because exponential growth is deceptive. A request that begins with 1 grain can outrun a kingdom simply by doubling often enough. That is the real twist of the puzzle. To make the number feel real, convert grains into volume. If 1 cubic meter of wheat holds about 15,000 grains, then this reward would require roughly 12,000 cubic kilometers of wheat. That is not a large barn or a large field or even a large royal storehouse. It is an absurd physical volume. So the inventor's request only sounded humble because our intuition is bad at doubling. The math turns a tiny favor into an impossible reward. If this puzzle fooled your sense of scale, the next one will twist your assumptions even harder. Click the video on screen for another paradox where something tiny turns impossibly huge.